All right, question 3. Let's do this. For the pair of polynomials given, select all the points of intersection of their graphs. Great. So we got two polynomial graphs. We earned equations that it wants to know the intersections on those graphs. So to do that, we need to know what the word intersection means. Intersection. It's where things touch, right? Intersection of football, that's interception. Intersection is where things meet, like the intersections of two roads. Intercept is very similar, a concept where it's where do things cross. So where do these two graphs cross? And how can we figure that out from the equations? It's very simple. If you see things talking about intersections, we need to know when does this graph equal this graph, right? What x values make these two graphs equal to each other? And so we just set their equations equal to each other. We go x plus 6, x plus 3, x minus 3, beep, 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 x minus 3 equals x minus 3. And we go, what values of x make this true? Now, the first thing that should stand out to you is both of these have x minus 3. And we've dealt a lot with sort of factors and zeros. What makes this go to 0? That's going to be 3, because 3 minus 3 equals 0. What makes this one go to 0? Well, it's the exact same, so it's 3. And if x equals 3, this part goes to 0, is multiplied by this part, and the entire thing equals 0. Over here, we get the same thing. So, at x equals 3, and I'll show you what happens when we plug it in. I plug in x equals 3, we get 3 plus 6. 3 minus 3 equals 3 minus 3. So we get 0 equals 9 times 0, which is 0 equals 0, which is true. So, at x equals 0, not x equals 0, what did we plug in? We plugged in 3. So at x equals 3, y equals 0. So we're going to select the option that says 3, 0, because that's the x position and the y position. All right? Now, we're not done yet. Let's go back to this equation. How can we, x plus 6, x plus 3 equals x plus 3. We got something on both sides. So if these two things are multiplied, and this exists on this side too, we can get rid of this by dividing. So let's divide both sides by x plus 3. Over here, what's x plus 3 divided by x plus 3? Well, it's something divided by itself. So in the same way that 8 divided by 8, or like 9 divided by 9, is equal to 1, this also equals 1 for anything. Over here, same story. X plus 3 divided by x plus 3. Doesn't matter the order you do that in. You don't have to divide by the x plus 6 first. Sorry about that. So, I can get this entire left side to be x plus 6 times 1, which is the same thing as x plus 6. I don't need that parenthesis anymore because there's nothing else on this side. Now I got to solve for x. We subtract... Oh, why would I do 5? I subtract 6 from both sides, and we get x equals negative 5. Bam! Now, that doesn't give you a y value, so we got to go back to the equation, and there's the equation up there, the x plus 6, x plus 3, and we go negative 5 plus 6, negative 5 plus 3, equals negative 5 plus 3. What's this? This is 1 times negative 2, which equals negative 2. What was I doing? Oh, yeah. So, both of them equal negative 2. So, at x equals negative 5, y equals negative 2. Your second point that you're going to select is negative 5, negative 2. So, that's the end of it. Our 2 points are 3, 0, and negative 5, negative 2. There also would have been a harder way to do this problem, which I'll sort of address right here, is if we took this and we set them equal to each other, we could have multiplied this left side out and gone x times x times negative 3. So we could have gone x squared minus 3x, then taken this, plus 6x minus 18 equals x minus 3, and then subtracted negative x or minus x from both sides, as well as added 3. So let's do that. And if we do that, we then get x squared. This is minus 3x plus 6x minus x. And don't worry if you're not entirely following along here. As I was saying, oh my lord, stop doing that. As I was saying, this is the much harder way. This becomes positive 2x, and then negative 18 plus this becomes plus 15, which equals 0. If we got this now, we have talked about factoring a quadratic. You look at this, you put x's on the left side, and we go, all right, what two numbers, when you multiply them, gets you 15, and then when you add them, gets you 2. Did I make a mistake somewhere? This might be hard. All right, so factors of 15. Negative 5 and 3. Oh, yeah, those are it. All right, my brain is tired. Factors of 15 are 5 and 3, 15 and 1. 5 and 3 are clearly going to be the better option. And what we want, though, is this. That's my mistake. It was literally impossible if this is not negative. So when that's negative, we can go, all right, 5, 3. It's either negative 5, 3, or it's 5, negative 3 as our pair. And we are going to choose 5, negative 3 plus 5 minus 3. Because when we add them, we get plus 2x. We can then look at this and go, all right, what are the things that make this equation true? Well, it's when x equals negative 5 and x equals 3. And then we would also have to find their y values. All right? Good luck.